Yes, we're going to test the toolpath. It's going to be the same DPC coin, except we're doing it on wood with a tapered ball mill to see what happens, and I'm using a radial toolpath, so this should be fun. So y'all get ready, hang in there. Alright, we're getting ourselves ready to spin this thing up. We're going to see what it does. This is a radial toolpath that I'm using, so it should be fairly interesting to watch. But I am testing toolpaths and testing bits and stuff like that, so it's either going to go really, really well or it's going to break. Either way, it's going to be fun. So let me go ahead and get this thing going. And this thing resting comfortably right there. Let's go ahead and turn the machine on. Up and running. Oh, the SD. Oh, we need no SD card. Hold on a second. You know how finicky these can be. It's like, there's no SD card in there. Yeah, there is. If you're chatting, I haven't seen it yet, so everyone hold on. Alright. No SD card. Why does it keep saying that? Does this to me every time. Every single time. Yes, there's an SD card in there. I promise. Card inserted. No SD card. Alright, hold on a second. We might have a tooling or a card issue here. Come on. Why does it say no SD card? I know there's an SD card. Anybody else have this issue with an MPCNC? Because that's the, I assume it's just the card seating. Could be that the fact that the might have been some debris in there. So let's check that out, see if it helps. Try it now. No SD card. Okay. Why is it saying that? There is an SD card. Card inserted, we know that. Card removed. Card inserted. No SD card. What the world? All right, let me this will take a second, and then what we're gonna do is, hey, what's going on, Cobra? Hey, I haven't seen you around in a while too, man. I'm gonna be doing just a coin pocket clearing, but I'm doing a radial path. Problem is, it doesn't want to read the SD card. So everyone hold tight. I'll be right back. I gotta go try and transfer it again and make sure the card's working good. Be right there. Okay. Hopefully we got it this time. It'll recognize the card. Here's the problem. I don't have the old SD cards that the Rambo board here uses. So the problem with it is I have to go into this very large SD card and I have to create a small volume on the card so that it can read the card. Instead of asking, there it is. Okay, we found it. SD card's there. So what it is when you're using a card that's like 256 gigs or whatever, and you can't find the small one that came with the card or came with the board, you have to go into disk management and you can allocate a section outside of the main volume of the card so that it can be read by the board. So you don't want to go over 4 gigs. So you reallocate that space, and then what you end up doing is you end up turning your 256 gig card into a 4 gig that's readable on the board. Sort of a last minute fix. So we're going to go ahead and get this toolpath on. Spindle's going to come on, and here we go. Cross your fingers. This is a radial path. Might be able to speed it up. So this is a radial path with a 0.1 millimeter step over with a tapered ball mill. we do have another tool path we're going to run after this, and it's going to be a little bit bigger, I think. So when this is finished, we're going to do another trace path. I hope you can all hear me. Hey, Review Gate, welcome. Sorry about the noise. How you doing? Welcome to the stream. After this test pass, we're going to do another trace path. I'm just trying to get this machine to work properly. I've been working on it for a while. Just about done with this one. We'll take a closer look at it, and then I will transfer the other file to the SD card, and we will run that path. But it looks like my new gantry is working out really well. We had a lot of backlash in the old one, and it was just too much, way too much. It was dragging the bit through the material. We already made this machine a lot bigger than it's supposed to be. So now we're just getting it milled out, and getting all the kinks out of it. right, let's move this out of the way really quick. Because I have to go get the other tool path anyway. That came out pretty clean for this not being a very hard wood. Giggity. But that actually worked pretty well. I am impressed with it. Not bad for a tapered ball mill. Need harder wood though. I can't say that without saying giggity right afterwards. All right, so what we're gonna do next is I'm gonna go grab that other tool path. Now this is how I'm testing my workflow. Basically shut the machine down, pull the card, go to my computer, and now I'm going to grab the, that's what she said. Another CG. You always got one for me, don't you? All right, so the idea is that I pull the card, I go get the other tool path that I need, I run it in here and I put it on here and I see how quickly my workflow can go from the desktop back to the CNC. So sit tight real quick, stare at my wood, and then I will be back with the next tool path. Hang in there, guys. I know you can do it. All right, I got the tool path. Now let's see if it reads the SD card again, or if it gives me trouble like it did last time. I'm thinking it's the screen, since the screen has the input for the tool path, or the SD card. I'm gonna try and go right centered here, because I think it starts. I didn't do a lead in on this trace path, so we're gonna drop it right about there. And I know it seems like weird to watch it like this, but hey, I'm doing what I can. All right, machine on. Let's see if our SD card is present. Not bad for overbuilding the CNC completely. Print from SD card. Got it. Spindle on. Now. Okay. That obviously did have a lead in. I apologize. Let's try that again. Not sure how far of a lead in, but we'll go right to the edge here. That traveled a ways, so we're gonna leave it right up there. How close is it? Close enough. All right, we'll start it there. See if it goes in the middle this time. I guess I did have a lead in. I don't have a lot of extra hardwood stock laying around, so I've got to go get some. And aluminum. All right, here we go. That could have gone a little bit deeper. So what I'm going to do is I'm going to shut this down. And I'm going to drop it. I have a feeling I'm going to ram this bit right into the wood. Giggity. We're going to run the tool path again. I'm going to try not to move it from where it is, where the finish point is. No, that's not low enough. Hold on. Hold on. I gotta get this thing lowered. I want that to be a little bit deeper. So we're gonna right up there. All right, let's try that. And hopefully it'll trace along the same path. At least that's my hope. So I kind of want to bring out the rest of that trace. All right. Let's move it out of the way so you guys can take a better look at this. Let's go ahead and... That is really cool. This is going to give you an opportunity to make some of those boxes I want for people. Yes, this is a rose, so it's obviously for my wife. But if you look, so we can not only mill any kind of jewelry boxes and things like that out of, you know, any particular hardwood, but we can put any kind of design on it and then stain it and then sand it out, and you get a really, really good result with a trace path. This is also going to help me when it comes to doing some custom stuff for the drone. The DPC coin, obviously, just another test. But yeah, that came out really good. I really like that. So if you want some custom jewelry boxes for the lady, just hit me up. Maybe I'll put them on my store. if anybody goes there and buys anything. Because you have to understand, we can play with power. My phone's going to be mad at me for it.
I wasn't finished.
Yeah, we know. Okay. The main reason why I'm setting this thing up and getting it dialed in is because of this drone. You've all seen the drone. You've all seen how big the drone is going to be. And we are currently printing basically everything we need to finish off these engines. This one's pretty much done. This one I'm still waiting on a center bearing for. I'm doing the ductwork now. It's the first part of the second part of the ductwork for that motor there. These two motors are done, except for the motor mount and, of course, mounting the engine, which is a really big 7070 110 kV motor. So I had to use the MPCNC to cut out my heat sinks for the motor mounts, because what I wanted to do is I wanted the fan to cool off the front face of the Outrunner as it was going. All of these are rigged with lights. They are all going to have, it's going to be a huge light show in the air. It's why it's printed in PETG. Yes, they're sitting upside down. That's how I'm going to have to put them together on the floor, because of it being a 5 foot by 5 foot drone. CJ, what's going on, brother? Welcome to it. You're right at the end of it here, but still, welcome anyway. So what we're doing now is I'm finishing up the rear two engines now. The front two engines are done. The body work for them is done. I've got to get some more of this carbon fiber rod. This is 16 ID 20 OD. So it's pretty thick stuff. I need like eight or 9 pieces of it just to make sure everything gets together. But we do have the two engines complete here. This one's done except for the casings. We're getting those finished right now. Everything's printing on the X1 carbon. We're looking at anywhere between 9 to 15 hours per plate when it comes to this ductwork. So there's a lot. This is actually 2 walls. So it'd be about 4 millimeter. And it's really just because I want my lights to show through. So I have a lot of lighting on this rig, and I'd be happy to show it to you if I can get a plug here. I've got to get power run to this place properly. I've got everything in the shop set up just about, but not quite everything. See if I can't do this with one hand. Maybe not. This one, I'm going to have to work on the, let me shut the light off so you guys can see. Going dark. All right, so this is one of them right here. So your interior and exterior lights are going to be going as the drone is going. Plus, it's going to change sequences because I have different lighting sequences for the drone. So the entire thing is going to be lit up, including the body, which is also going to have lighting sequences in it. And these as well. So every engine's going to have it. And the whole idea behind this is obviously cutting the metal parts I need to cut, getting those done. The machine's working beautifully. It's definitely got some accuracy going on as far as trace patterns. And using that ball mill, it actually came out really good. I lost the screen for a second, so I tried to call. So, can I tell you what I'm making? I am making the largest 3D printed EDF drone in the world, as far as I know. It's an 11 blade, high pass. The shorties are for the cooling fins underneath. Keep everything nice and cool. It's actually working pretty good. Let me do something for you here real quick. Okay. Let me set this up really quick so you can stare at the lights while I power up this engine. Ouch. Okay. Stare at the lights. So, hold on. I got to hook this up. Radio's on. We are doing a test. This ductwork hasn't been attached yet, so that's fine. We're going to move that out of the way so it doesn't get blown all over the place. And I will power up this engine for you. Up and right. Okay. Sorry about the interruptions. I keep getting calls. Let me go ahead and plug this up here. You're going to hear the pop as I plug in the 48 volts. Now this is going to run, keep in mind, this is going to run on 75 volts, not 48. 48 is my testing wattage. All right, and we're obviously not going to ramp it up too high because I don't have this thing chained down like I did last time. So. So as you can see, it works pretty good. Can't go any higher than that because the torque of the engine is moving the whole assembly. Kind of gives you an idea of what I'm having to deal with. And it's... Good Lord, okay. That's got some torque. And at 48 volts, that's nothing. We can push this to 5,000 RPMs, easy. But when it comes down to putting this thing on the 18S packs, it's 9,000 RPMs. And everything holds together really well. If you look at any of the other tests that I've done with this engine, I've kind of ramped it up to max throttle on the 48 volts. And everything held together. And what's going to really surprise you about that is that each one of these blades are printed separately. And they are actually friction fit into the hub. No glue is holding this together. 4 8mm screws, or bolts, I should say, are holding the hub to the main shaft, which goes through to here to the tapered roller bearing, which gives me my stability. Plus, it gives me the collet for the engine to mount through. And then, of course, my motor mount goes here. And that's what the motor mount kind of looks like. This is an older one. But that's where we're at right now. This thing puts out a lot of air. Like a lot. And at 75 volts, we're going to peak at 9,000 or so RPMs. This 5-foot by 5-foot EDF drone is pretty much completely 3D printed and it is going to fly. Not pretty soon. Hopefully when I'm done printing all the ductwork, I get the whole thing assembled because it's going to have to be on the floor. I have to take everything down, move this table, get it on the floor, get it put together. It's going to take a lot. This right here is for the metal parts that I need for cooling, things like that. Plus, it's also for mold making because a couple of these engines I'm putting together here, I have they're smaller buddies. Where is it? Right here. The 22 blade high pass. Engine sits in the front and then the ductwork will pull everything I need around the motor to keep it cool. This will go into, I was thinking about an SR72 model. Put a couple of those in. And these run off of the same 7070 motors that's pushing these. The only difference is this has 4-to-1 gear ratio in it. So it's able to spin it much, much faster. So that's going to be fun. Modular engines for bigger aircraft. But knowing that I have to do that in order to make the body parts, we want to be able to cut out the rib spars and all that other stuff on here out of a thick balsa or a thin ply, that kind of thing. And then we also want to be able to put that foam board on there so we can cut our molds for the body work, so we can vacuum, you know, do the carbon fiber vacuum wrap kind of thing. That's going to be a bit longer of a project to do, but it's going to be fun. And that's why I've been working so hard to get this machine working properly. We got to get Sally in the air. We got to get this one in the air. We cannot, absolutely cannot forget our friend, the Dill drone. We can't forget that one. If you look for the videos on that, it flew pretty good. I just didn't have a battery voltage indicator. I tried to land the first time. Should have went with my gut and changed the battery, and I crashed it. But it still works, so it's all good to go. I just got to get some more props and stuff for it. So, let's see. Hold on. I'm getting questions. Wait. Let me unplug this ESC before I accidentally grind my hand off. 1 second, and I shall answer questions. Engine's off. Okay. All right. Let's see. How did you pull off no glue, though? Oh, friction fit. I designed the fans to be CNC'd out of a aluminum, like a 7075. So the tolerances I put on there are very small. So as I seat each one of these blades, you can hear it clicking past each one of the layer extrusions. So I just tap it in with a hammer until they're all the way down. And no glue. No glue whatsoever. Let's see. What else do we have here? Like the steel kind of fan mount. Yeah, I do need a steel fan mount. I'm thinking about having that printed. Because I don't have a 5-axis to get one done. I would love the entire drive system from the fan, the hub, the main shaft, all the way through to the collet to be out of an alloy. But finding an appropriate desktop CNC machine that I can actually afford and still keep most of my vital organs off the market is fairly difficult. So I'm kind of waiting to see what comes out, to see if I can't, you know, put myself together like a loan of some kind to get a nice CNC machine so I can do the work myself. Because if I had to have these sent out, it would cost so much more. If I sent out every part I wanted alloyed to someone who professionally CNCs things like this, I could literally afford to just buy one. They want over $2,000 per fan to CNC this out. So, and that was at the 170 millimeter size. That was at the small size I showed you over there. Not 340 mil. I haven't even got a price for that one yet. That's scary. I don't even want to ask. I might as well take out a more, you know, like a second mortgage on my landlord's house. Oh yeah, we could do some wood accents to it too. That would be really cool. The blades RPM limit, I'm going to be above the RPM limits, but I can do 5,000 and torque it pretty hard on the throttle, and it seems to be okay. The going from 48 to 75 volts is definitely going to push the limits of the blades, but the idea is to get them made and get this thing in the air, watch it fly. When it's proven that the technology works good, the design works good, then even if I lose a blade, something blows up, whatever, we know that it'll fly. I mean, if I get a 2-second hover out of this thing, and I know I'll get more because if you watch the original Shrike from the concept drone playlist, the little tiny one I did with 70 millimeter EDFs, the idea is sound. It does work. I kind of went overboard on the size, but I ain't go big or go home, right? So that's the whole point behind all this. I'm not here to build a tiny little project. I'm not here to build something that drone enthusiasts everywhere can download and build. No, this is something for me to build. This is a challenge for me. And it's also a possible device that could be used in search and rescue operations, fire mitigation, all kinds of stuff, especially when it's done with the right materials. The idea is having a closed prop system. Makes it more versatile. It can get in and out of places that some drones can't. And for search and rescue, for fire mitigation, things like that, when you're having to get down in the brush, that kind of stuff. I want to put those fire extinguishing grenades on these things. You know what I'm talking about? They have them. I haven't seen a commercial for them for a while, but they have them in some houses or some businesses where it's just, if there's a fire in a specific area, you throw the grenade in there and it goes off and smothers the flames. Well, you put a cannon on this thing, it'll fire those into hot spots in a wildfire area. You can get in and out quick and put out a fire, or at least drop the hot spots down. So it could be used for that. It could be used for, like I said, search and rescue. It could be used for dropping in medical. Somebody that's injured, somebody trapped on a roof. It could pick them up out of there. It's got 472 pounds of thrust total. And the whole drone weighs just above 70 pounds. So I already have a tail number for it with the FAA. So when I do test it, don't worry. Got my bases covered. Trying to make sure that I don't get in trouble for launching this bad boy. You know, I am going to do a hover test in my backyard. That's going to be scary enough. I'm not going to go over my house, but it's to make sure that the PID loop is good. And then if I have to change anything, then I got to go back. So I don't want to take it all the way to the field. And it doesn't fit on my car. I got a Chrysler 300. Older car, no rack. So I have to figure out a way to transport this because it won't fit on top of it's not going in the car. I'm going to have to buy a truck or something, which I can't do. So I'll have to borrow a truck. I mean, Rhett, I know you're watching and you have a truck. So when we test fly this thing, we need to be out somewhere else. My brother actually wants me, it's a Speedy B on iNav. It's a Speedy B F405 wing that's controlling it. And that's controlled by iNav. That's what I'll be doing, another CG. My brother wants me to drop him into the reservoir with this thing. So it will lift him. He meets the weight requirements for a lift. So we're going to test payloads with the blade that I have here. Ultimately, I'd like alloy blades to do any major lifting, but it will lift its own weight plus some. And my brother wants to do it. He's like, we'll get a harness with the check pins where you pull the release and drop them. He wants me to take them up to like 30, 40 feet and drop them into the lake. So you guys don't want to miss that video because I'm probably going to get in trouble right after. But I'll have all the appropriate things set in place. You know, EMTs, licensing, all that other good stuff, insurance. That's why I LLC'd. That's to protect all my guinea pigs, test pilots, to, just in case something happens. So as this thing progresses, keep in mind, this isn't the biggest version of this I'm going to create. This is half the size of the one that you're going to ride like a quad, like an off-road quad. Who needs tires, right? You can fly just off the ground or just above the trees. Or if you need to make a quick stop to the grocery store, hop on the turbine quad. Go to the store. You won't catch anyone's attention. You'll fit right in. It's better than the flying cars that they came out with right now, where you need a helicopter pad. That makes no sense. Can you imagine Black Friday and people flying around with those things? It'd just be like all the way across the top of people waiting in line. You can't do it. You can't sell a flying car if it requires a helicopter pad. Then it's just a fancy helicopter. So I'm here to solve that issue with nothing more than the money from my left kidney. I'm kidding. I'm playing with you. Eventually someone will jump on board. DARPA. Anyway, the point is, we don't want Boeing to do it because we want it to work the first time. I kind of do the Elon Musk kind of iterations where that might work. Let's do it. It blew up. All right, let's do it again. That seems to work better for me. And it's more fun. Let's just face it, right? So for everyone who has been watching, please subscribe. Please share it with your friends. Make sure you check out the merch store. I don't know why people don't like the merch. Probably because they haven't seen the strike in its full glory yet. You'll understand the hoodie after you see that. But I got mugs. I got all kinds of stuff. You can become a member of the channel if you choose to. That'd be great. You don't have to. I'm not going to make anybody. But it helps me continue to bring you more content. And that's the whole point. That is the whole point. Because I'm doing this all for you guys. It's fun. I'm doing it for me too. But I mean, to entertain people. For them to see this and go, if it inspires you to create something, that's the whole point of this hobby. So, with that being said, I want to thank y'all for being here. Hey, buddy, what's up? You look lonely. Deadpool's up here. Hang out with him. You can get a Stubby Fan mug on the site right now. And that is the Stubby Fan. And if you look up any of the Stubby Fan playlist, you'll see why that one was so much fun. Get your mug today. Get a hoodie that your girlfriend can steal from you. Because I know as soon as I get the hoodie, because I'm going to order one for myself. But when you order something, when you order a hoodie for yourself, we all know that it's for the wife or girlfriend, because you're not going to keep your hoodie, bottom line. Yeah, flying drone car, basically. There's the wife now. She's like, yep, the hoodie's mine. But yeah, the idea is, because I don't want to do that whole thing like they did with the Volanaut bike. This is going to be hydrogen electric. This is not going to be just battery operated. So you're looking at hydrogen PEM membranes, fuel cells, the whole 9 yards for the bigger version. Because the Volanaut thing was cool, but having a kerosene turbine right there next to your crotch, not something I'm willing to deal with. Okay? And I'm going to tell you right now, as somebody who's been into aircraft engineering for a little while now, if you notice in any of those videos, he does not bank. He does not bank like you do around a corner on a motorcycle. And you know why? Because he's sitting right over the center of gravity. The moment he banks past 20 degrees, or even less than that, he's on his face. That's why you've never seen it. You've never seen him bank. Slow, listing movements, that kind of thing. No. You need a center of gravity, which holds the weight, and you need push at all four corners. Sure, you could probably do it center line, but who wants to be on one of these things when it flips over? I don't want to be on a kerosene-driven turbine when I decide to bank and then end up on my face. And then now the turbine's drilling me from freaking the crotch down into the freaking asphalt. No, I don't want that. Besides, let's be real. I'm 6'4", 290. He didn't design that bike for me. Okay? He designed it for, I don't know what nationality he is, but he's probably just like a petit little Frenchman. You know? Like freaking Mario. Sitting on this little tiny bike. Yeah, it's a great idea. It's a good invention. If you're, 4'5", and you don't want to bank anywhere. Because I know you guys. You want to get on one of these things, you want to hit a bank and feel the G's. I mean, you just want to be around that corner, and that's the whole point. That is the entire point of this. And what you're looking at is the proof of concept for the big boy. As if this isn't big enough. And keep in mind, I had to design and print this thing all with one printer. One Bamboo Lab X1 carbon. And believe it or not, 28 kilograms of PETG is what it takes to finish this thing. And I haven't had to change the nozzle on the X1 carbon yet for this project. One hardened steel nozzle. So far, well over 20 kilograms of PETG. The total will be 28. I got to finish up the ductwork, though. And then I got to get it on the floor, and I got to get it assembled. But I'm going to tell you, right now with 4 120 amp 18S MAD components, ESCs, 75 volts total. The motors can handle 75. They can push 100 amps. It's going to be like a 747 taking off from the backyard. That's what it's going to sound like. It's going to sound beautiful. Beautiful. Think of the original Shrike in the Shrike Concept Drone playlist. Look for the V10 Maiden. That's where I showed it off. Think about that drone and the sound that it made, except like 5 times the size, 6 times the size. That was 70 millimeters. This is 340 millimeters. So maybe not 5, 7 times. I'm not really trying to do math right now. So I'm glad you all stopped by. I'm glad you enjoyed what you saw. And just remember, don't miss any shorts, because the shorts are the updates for the long run videos and for maiden flights. Don't miss them. And if you like listening to relaxing music, I did put together some of those ambiance videos for fall. Maybe your girl would like it. Maybe your wife would enjoy it. They're really cool. So check them out. You'll see them in a playlist there on my page, along with all of my social media links and the link to the DPC store. Get that hoodie, because you know your girl's going to take it. I want to thank everyone who has stopped by today. You have all been wonderful. You've all been great. The Molar X. I'm getting ready to end it. You mentioned something. What's the Molar X? Come on, another CG. Molar X. I'll look it up. Because our temperatures have not been forgiving here lately. And it's a brisk 95 degrees in here. And I am slowly roasting. I shall be done in a few hours, and then you could turn me over and baste me. That sounded really bad. Anyway, thanks from the 90s. I'm going to look that up. I will look that up, I promise. Molar Skycar. I will look that up. Molar definitely sounds hydrogen. All right. Thank you all for stopping by. Thank you. I hope you enjoyed the video. Like I said, like, share, subscribe, go buy stuff. Please. Come on, we're getting into the colder months. I've got fleeces there in warm weather gear, coffee mugs, tumblers. Yeah. You may your girl's got a Stanley. Get something with the Shrike Ultra on it. I got tumblers. I even have coffee on the site because I wanted to see what coffee I could get. So you got to check it out. I think you'll enjoy it. Again, thank everyone for stopping by. Your support means the world to me, and it helps me keep going. It helps me keep going, and it helps me sit staring at the screen, catting more projects while I'm waiting for 19-hour prints to get done. So thank you again, and I will see you all next time. You all have a wonderful evening. Thanks for stopping by Drone Power Concepts.